Hello and welcome back to SVSU's online tutoring. My name is Joel and we will be continuing on with complex conjugates. This is part 2, and so where we left off was at writing complex numbers of a quotient in standard form. And we'll just be doing one more example of that, where we now look at opposite signs within our numerator and denominator. So if we have 5 plus 4i being divided by 7 minus 3i, what I have to do to write this in standard form is multiply both the numerator and the denominator by the complex conjugate of my denominator. So I can write 5 plus 4i multiplied by 7 plus 3i. Let me fix that 5 here. There we go. And in my denominator I have 7 minus 3i multiplied by 7 plus 3i. And what we have to keep in mind is that in our denominator we have our standard form for complex pairs. So that's minus bi, which is equal to a squared plus b squared, okay? So our numerator, what we can do is that we can FOIL this to simplify it. So we would have 35, let me make that 5 better. I always struggle with the 5s, with the pen here. 35 plus 15i, and then we move on to our second number, so plus 28i, and then plus 12i squared. And all that is being divided by 7 squared plus 3 squared. Whoops, not 3i. 3 squared. I even said it, but I still wrote it wrong. Okay. And that's because we have the conjugate pair in our denominator, right? So we can just use our general definition. And so in our numerator, all we have to do is combine like terms. And so this 12i squared can be rewritten as negative 12. So we have 35 minus 12, and then 15i plus 28i gives 43i. And in our denominator we have 49 plus 9. So 35 minus 12, that's 23, and we have 43i right there. And then 49 plus 9 is 58. And none of these numbers share a common factor with anything, or with each other rather, so then we can just go to writing it in standard form. So we have 23 divided by 58 plus 43 divided by 58i. And finally, if we wanted to verify the complex solution of an equation, so say you were given a solution to some equation, and that solution was x equal to 3 plus 2i, and our equation was x squared minus 6x plus 13, okay, equal to 0. So all we have to do here is that we have to take our x and substitute whatever it's equal to into our equation here, okay? So we have 3 plus 2 squared, let me fix that, 3 plus 2i squared minus 6 times 3 plus 2i plus 13. And is it equal to 0? Well, we don't know, so we just put a little question mark right there. Let me fix that 13 real quick. There we go, make it a little bit better. So we can expand this, and we have 3 plus 2i multiplied by 3 plus 2i, and we can distribute our 6 in. So we have negative 18 minus 12i plus 13. And we have to FOIL what's over here. So we have 9 plus 6i move on to our second term, and we have 6i plus 4i squared. And so now everything is completely expanded and now all we have to do to simplify is just combine like terms. So this 4i squared will be rewritten as negative 4, because I squared is equal to negative 1. So we have 9 minus 4 minus 18 plus 13. And the two 6i's would give us positive 6i, and that's minus 12i. So is that equal to 0? Is that equal to 0? We still don't know yet. So the 12i's cancel, okay? And now we're just left with what's left over here, right? So we have 9 minus 4, which is 5, minus 18 plus 13. And this positive 5 plus 13 gives us positive 18. And so we have 18 minus 18, which is equal to 0. So, yes, this x equal to 3 plus 2i is in fact a solution for our equation. Okay, that is the end of chapter 7. The end of chapter 7. We'll start chapter 8 in the next video, and that will be about where is it? The quadratic equation, functions, and inequalities. Okay, see you next time.